Chapter 7 Additional Topics in Trigonometric Function under 7.4 Graphs in Polar Coordinates. The objective is to sketch the graphs in polar coordinates. Graphs in polar coordinates. The basic method for finding a curve in polar coordinate is by assuming the value of theta and then find the corresponding value of r. So you must start from theta, then find r. These points are then plotted and joined, thereby forming the curve that represents the relation in polar coordinates. For example, sketch the graph of the equation r equal to theta over pi. So you have to determine the value of theta first. You can use this set of value 0, pi over 4, pi over 2 and so on until 2 pi. And for each corresponding value of theta, you have to find its r. Theta 0, when you substitute theta 0 into this formula, you will obtain 0. Then if you substitute pi over 4 inside this formula, you will get 1 over 4. You have to continue until the table completes. Then you have to plot all the points in the table. For example, the value of theta is the direction here, and the r equal to theta is in the origin. At pi over 4, you have to plot 1 over 4, and pi over 2 you have to plot 1 over 2. Look at pi over 2, the length is 1 over 2. And then after you plot all the points, you have to join them and sketch the curve. Another example, example 2, the function given is r equal to 2 cos 2 theta. First, you have to construct the table that consists of the value of theta and its corresponding value of r. After that, you have to plot each coordinates. Then you can join all the points to make a curve like this. Okay, so this function will give you the shape of 4 petals. Now we want to go deep into polar circle. Polar circle has the shape of circle, and the equation is in the form of r equal to 2a sine theta, or you can put negative in front of the function, or r equal to 2a cos theta or its negative function. So each format will give you a circle but on a different location. Look at the first one in the first row, denoted by blue font, r equal to 2a sine theta. It is a circle with radius a, center at rectangular coordinate 0a, and the curve is given by this blue curve. This is a circle with radius a and center at 0a. Now let's look at the second row. When you have negative, the circle will move downward here. It's still a circle with radius a. Now the center is at 0 minus a. Next, r equal to 2a cos theta is given by this green curve. It is still a circle but on the right hand side with radius a. Now the center is a0. Lastly, when you have negative 2a cos theta, it will move to the left. Still a circle with radius a and the center at negative a0. So generally, the polar circle is represented by 2a sine theta or its negative, or 2a cos theta or its negative. Example 1. Sketch the graph of r equal to 4 sine theta. So you have to start by providing a table that consists some value of theta, and you have to evaluate the value of r. For theta, you can take this set value by increment 30 degree we stop at 180 first, and for each angle we substitute into the formula. If theta is 0, r equal to 4 sine 0, it's equal 0. Then if theta is 30, your r is 2, and you have to fill in, complete the table. Next is to plot on the polar coordinate system. In the polar coordinate system, the 0 degree always at the right hand side, like this. And if we going upward, we get 90 degree, 180, 270. And 30 is here, 60, 120. So we complete the table. Okay, now look at theta equal to 0. So the direction is here. And your r equal to 0. R is the radius from the center. Let's put the scaling here. The first ring as 1, 2, 3, 4. Means that this ring will give you 1 unit, and the second ring will give you 2 units distance from the pole. R equal to 3 is here, and r equal to 4 is the outer circle. At theta 0, r equal to 0, so the length from the pole is 0, which means the plot is at the origin or the pole. Next, we focus on another ray, which is 30 degree. So along this direction, the length from the pole is 2. So you have to measure, this is 1, this is 2. So this is another plot. Then at 60, we are focusing on 60 degree, which is this line, and the length is 3.5. So this is 3, this is 4, so 3.5 is the middle point between 3 and 4. And look, at 90, the value is 4. So look at 90 degree and evaluate the distance from the pole by 4 units. 1, 2, 3, 4. So it's at the outer ring. Then we continue 1 to 0. 3.5. 150 is 2, and 180 is 0. So by now, we can see the pattern of the plotted points is a circle. Then just join all the points to make a circle. We can also check by the theory. Look again at the function. The circle equation is generally represented by r equal to 2a sine theta, right? So here, if you compare with the value, the 2a equal to 4, so means that your a or radius is 2 units. So you can check here from your circle, the radius is 2 units. It is consistent with the theory. 2a sine theta is located at the upper part here, okay, and the center is 2, 0.